In this presentation, we are going to see how agent-based models aim at testing the policies obtained from the backcasting scenarios and also at investigating how to make them more effective. Just a brief reminder, the agents were modeled, as my colleague has just said, were modeled as individuals using the data collected through a questionnaire in which we had personal data, values, identity, efficacy, norms, and behaviors. And each agent may have a different profile obtained from the values in the questionnaire. So we have biospheric, altruistic, egoistic, hedonic agents, and also mixed profiles. And the behavior of the agents were also obtained from the data in the questionnaire using decision trees that were automatically obtained using machine learning techniques, but then were reviewed by an expert to assure the theoretical consistency of the results. Well, the agents are immersed in an environment which is one of the 6 organizations that we studied in the Locale project. And finally, agents interact with each other in two ways. Agents have relations with their peers, and this forms what we call the personal social network. And also the agents have relations with their subordinates or their supervisors, and this is what we call the organizational social network. Most organizational social networks are hierarchical, as we can see here in one example for one of the organizations, which is the University of A Coruña, UDC, in which we can see the structure of the organization in departments and research groups, and in which the colors that we see there identify a different profile in the agents. Okay, so now we go to the simulation of the different scenarios derived from the backcasting to investigate policy recommendations for the organizations. The aim here is to see how the dynamic interactions between the agents can affect the policies in the mid and in the long term. And the policies that we tested imply changes in the 3 dimensions that I just have said: agents, environments, and social network. And we will see isolated interventions like hiring biospheric personnel or restricting the use of the car, and also the combination of different interventions. Well, let's go to the first one. The first is the hiring of biospheric personnel. In the figures in the upper part, we have the number of agents per profile in each of the 5 profiles that were derived from the UDC, the University of A Coruña. In the left side, we have the present situation in which the ratios have been maintained until 250, and on the right figure, we have a simulation in which in year 250, 50% more of the personnel belong to the biospheric profile. In the figures in the bottom part, we have the transport type used by the agents, and although there is a slight decrement in the use of the car, it's not very important. In this figure, we can see the effects of hiring biospheric personnel in 3 different percentages and the present situation. We can see that, well, 0, which is the blue line, is the present situation. The differences between hiring 10% more and 20% more of biospheric personnel are not very important, and they decrease considerably with time. Until in 250, there is almost no difference. And also, the difference with 50% also decreases with time. We made an extreme simulation with this policy, and what it's shown here is a situation in which all the personnel in 250 in the university belongs to the almost all, belongs to the two biospheric profiles, the pure and the mixed one. As you can see, the green lines have a number of agents and the others almost have none. And here we can see the hierarchical social networks. This is the present situation. We have all colors. And this is the 250 simulated situation. Everyone is almost green. And this is the total carbon emissions, in which we can see there is a decrement with time, and the use of the car also decreases, but apparently the influence of the biospheric profile here is not very important. Now let's move to another different policy, which is the reduction of car use. This policy is very interesting for the University of A Coruña because mobility, and specifically the use of the car, accounts for 80% of the total carbon emissions. If we perform the policy but isolated in time, and we are affecting the environment, this is a policy that affects the environment of the agents, while the previous one affected the agents. Well, we can see that there is a reduction because we apply the policy, and the agents react using another transport, but then car use is progressively recovered with time. And why? Well, it's because of the social network. If we see this figure, the blue line is just what I have shown before, and the red line corresponds to the elimination of the social network, thus affecting two of the dimensions, the environment and the social network. If we eliminate it, car use is not recovered. So social network, as my previous colleague has said, is very important in the policies. And these are the total carbon emissions for the policy. It's interesting to say a thing here. Car use is recovered, but daily emissions decrease. And why is that? We have this because the model, the model considers technological improvements that are applied on the system. And so this is the reason why the daily emissions decrease. If we eliminate it, daily emissions will increase, which is what we expect. And from now on, I will show the total carbon emissions without technological improvements, so we can see how the policy affects the situation. But the model contains them, so to be more realistic. Well, what happens now if we apply the same policy, car reduction, but instead of making it at a point in time, we maintain it through time? Here we can see the results of two of the simulations with a 30% of reduction and a 50% reduction. And in both cases, we can see that we can evolve to situations in which car is not the first transport used in the organization. And here we show the total carbon emissions corresponding to both percentages. And there are a couple of things that are, I think, of interest in these graphs. First one is that we can obtain total carbon emission in 250, interesting, around 8 tons, which in the previous slide were around 20. And that there is no difference, not very important at least, between an aggressive reduction, 50%, and less aggressive reduction in car use, 30%. The level of carbon emissions is almost the same in the long term. So that's interesting. And just to be brief, we have simulated another policies, like the encouragement of the use of bicycle, isolated and also in a maintained way, and the results are similar to the previous case. So I will go to new experiments in which we combine policies. This is the first one that considers two policies, both affecting the environment, and both are duplicating the use of bicycle. We did this because in the university there is a very few people who use the bicycle, and reducing the car, but now in a very low percentage, which is only 10%. As we can see, the reduction in the car is maintained, and the increase in bicycle also, and the daily emissions decrease also to levels similar than in the previous experiments, but now with an even mildest reduction in the use of the car, only 10%. This is a figure in which we put the three policies. This is the combination of both. We can see that in the mid and long term, the results are much better than if we used both isolated policies, and of course maintaining it, it's better than doing it in an isolated way. Well, now we check another combination of policies. These two use a policy affecting the agents, higher biospherics, and another one affecting the environment, use of the car. And as we can see, we evolve to a situation in which car is greatly reduced, and the carbon emissions obtained in 250 are also in an interesting level. Again, this is the comparison of the situations. We can see that the red line that corresponds to the combination of both policies obtain much better results than the policies separately. And as a further simulation, we simulated car reduction again, but promoting higher values in different individual factors, specifically in efficacy, identity, and norms. And as we can see, well, efficacy corresponds to this line, blue line. Identity, it's the yellow one, and norms is the red one. As we can see, norms appear to be the most significant, the most influential. As norms are so influential, we did new simulations in which separated the norms in those related with supervisor-subordinate relations and others affecting colleagues. In the case of the supervisors, and with the policy car reduction, we can see that car is reduced, and the agents react to the norm. But then slightly with time, car is reduced again. A similar situation happens with colleagues' norms, but now the reaction, as you can see, is a little smoother, although a little also prolonged in time. These are is a figure with a comparison, and as we can see, if we promote higher values in the norms related with colleagues, we can obtain slight better values. Just briefly, we go to another simulation, which is the energy consumption using computers and lights. Computers are the blue line, right? For lights, we have three behaviors in the other colors. And this is the present situation. You see that there is a stable number of energy responsible users. These are the daily emissions due to computer use and to light use. If we simulate what happens with a campaign that tries to make people more aware on the use of the computer, so they turn off when they're going home, we can see that we obtain the desired results. The number of agents is increased and then remains stable. On the right side, you see the daily emissions due to computer use that are decreased, yes. And on the upper part, we see the total daily emissions. As you can see, the problem with emissions in this organization, the GDC, is that it's mostly due to mobility. And so we cannot appreciate anything, almost. That's the reason we put it in another graph. Well, for the lights, we have similar responses. Campaigns appear to be effective. And this is another policy, which is the use of a campaign. So we make people more aware of the need to recycle paper. In the discontinuous line, we have the present situation. Users of recycled paper and people who recycle paper. Solid lines are the results of the campaigns. As we can see, we obtain the desired results, and the users remain more or less stable. Well, I would like to say that all the results that we have shown belong to the simulation of the policies in the University of A Coruña. But of course, we have the simulations corresponding to the other organizations that will be available in the deliverables. But we thought this will be better so you can have a comparative picture of how the policies work together over the same organization. And as conclusions, we have this. If we use policies maintained in time, we can obtain better results than isolated interventions. Combining policies works better, normally. Individual factors influencing the order, norm, efficacy, identity, and values. Social networks are very, very influential in the long term and affect very much the result obtained with the policies. Mild intensity policies can work better than more aggressive ones. And the campaigns for recycling and energy consumption work better than the campaigns for the use of the car, which needs really more efficient policies, as we just have seen.